Let me introduce you to support vector machine and support vectors. I'm also going to talk about complexity of support vector machine, and I'm going to introduce you to Kernel Trick. You will see a demo of Kernel Trick using Excel. So let's first understand what is support vector machine. Support vector machine is usually used as classification technique. So if you have two classes, then it is first all about finding a hyperplane which can separate these two classes. Now if you look at, there can be more than one line which can separate these classes. For example, even these two lines can probably separate these classes. But then how will you decide that this is the line? The trick is that you go for those data points like this data point and these two data points which are closest to the other side. Similarly, this data point and this data point is closest to the other side. And then you find that particular plane which is having maximum margin from both sides. So that's how you are taking this. You are not taking this because it is very close to the one side, and neither you will be taking this because it is very close to this side. You are in fact taking that particular hyperplane which has maximum margin from both sides. Now what are support vectors? Support vectors are coordinates of training example which are closest to the classifying hyperplane. Or in other words, you can say that these are the closest to the other class of the data. In fact, these are the most difficult to classify because they are the closest to the other class. You will not have confusion here or mistake here, but there is a possibility that you can go wrong here. If I ask you how many support vector points appear in this particular example, you can probably pause the video and try to take a look. If you look at, I will call this data point, these two data points, and this data point as support vector points. The coordinates of these points will be called support vectors. Now one question comes that linear discriminant analysis, logistic regression, classification tree, all can do classification. Then why SVM is so popular these days? It is all because it can be used to separate linear as well as non-linear space fairly quickly. Very quickly you are going to understand the kernel trick which can be used to separate non-linear space. Because it leaves maximum margin both sides, if you recall, it is leaving maximum margin both sides, it is less prone to misclassification error. And that's why it is less likely to result into overfitting. One more thing which is very important, that its complexity with number of variables is linear. So if you had 50 variables, the moment you go for 100, the complexity, or in other terms the time taken for execution, is just double. It can work even with the smaller data sets where some of the technique may not be applicable very well. One point you need to keep in mind, especially when you are talking of humongous data set and non-linear separation, the original format of this particular technique may not be very suitable. The reason is that its complexity with number of records is NQ. So if you have 50 probably million of or 50,000 records, and the moment you go to 100,000 records, which is double the number of records, the complexity is not double. It's actually 2 to the power 3. So that way it becomes 8 times. Of course, there are variants which can take care of this situation, but in its original format you will struggle. Now let me introduce you that how you can classify non-linear space into linear space. That's the kernel trick. And kernel trick in one line is all about transforming non-linear space into linear space. For linear cases, you can come up with cases like a1 plus b1 into x1 plus b2 into x2 if it is greater than c, class 1, and if it is less than equal to c, it is class 2. In case of non-linear separation, probably you do not have directly x1, x2, probably you have x1 square or square root of x2. And that's where lies the trick of kernel. In fact, you can introduce new variables, new features like f1 equal to x1 square or f2 equal to square root of x2, and that can separate this non-linear space into linear space. Let me show you two demos and then I'll come back to this point once again. So if you take a look at this particular case, I have taken 1 square, 2 square, 3 squares, and here are the numbers. If you plot this, so this like x and this like y in a scatter plot, you will find that this like is separable but not linearly. This like this, there is a hyperplane here which can separate. But the moment you take square root of x and you call it x1 for example, it becomes 1, 2, 3, 4, 5, and then you look at it is linearly separable. Let me show you a case which appears complicated but again can be solved fairly quickly. So here you have eclipse kind of data, and here you have x1, x2, and here this is actually like in Excel I have generated using some function of x1 and x2 itself. If you are trying to plot this, this will come like y for you and this will come like x for you in xy scatter plot. Again in another curve, this will come like a y for you, this will come like a x for you. So if you take a look at this space, this is not linearly separable. It looks like ellipse or even circle will get solved like that. And if you get a look, you'll find this particular line is separating out. Anything above 1, above this yellow line is like class 1 and below is class 2. If you recall, in geometry, like the radius is actually like x square plus y square, and you can actually apply a similar concept here because it looks like eclipse. And you take a look, I have applied x1 square plus x2 square this case, and now I'm putting x1 square and x2 square as x-axis and putting these good and bad as y, and you can see it became a linearly separable. The point that I'm trying to say to you that kernel trick it's all about using transformation of variable to convert linear space into linear space. Like this space became linear the moment you took square root of first variable. In this case, it became linear when you introduce a new variable which was x1 square plus x2 square. That's what I wanted to talk about SVM. You can subscribe to this channel. I keep adding new videos, and also please feel free to add your comments. Thank you.